So if we take a minute to talk about a few strategies with titrations. In this class, we will titrate strongs with strongs, and we will titrate strongs with weaks. We will not titrate weak with weak. That goes a little bit beyond the skill set that we expect at this level of chemistry. So strong with strong and strong with weak. I really don't love giving you something that sounds so prescriptive, but I know titrations are hard. So I want to make sure that you feel like you have a good skill set for working with titrations. Strongs with strongs will always have the net ionic equation. Strong acid plus strong base makes water. Because in this class, we're calling these things strong bases. When we're putting that, when we have a sodium hydroxide, lithium hydroxide, potassium hydroxide, when we put that in water, it dissociates completely to give us OH minus free floating in solution, and we're calling that a strong base. When we put things like HCl and HBr and HI and perchloric and nitric and sulfuric acid in solution, they release H plus completely, and this is a strong acid. So when I say strong acid plus strong base, that means H plus plus OH minus yields water in the net ionic equation. Well, weak plus strong or strong plus weak, when I say it backwards and forwards like that, all it means is one of them is in the beaker, the Erlenmeyer at the bottom of a titration, and one of them is in the burette. And you need to know which is which. But if it's a strong acid with a weak base, it's going to be the same H plus strong acid symbol, and a generic symbol for a weak base is B. It's going to make a BH plus. These are all limiting reactants because one of the components is strong. So anytime you add anything together in these types of reactions, you're going to do a limiting reactant equation to see what's limiting and then know where to go from there. So we said strong with weak, that could be H plus plus B, so a strong acid with a weak base, or it could be strong base with a weak acid. Makes A minus and water, yeah? Because one of the components is strong, it's a limiting reactant again. I said you need to know which is in the beaker and which is in the Erlenmeyer, but the net ionic equation is the same when it's a weak base with a strong acid or a strong acid with a weak, or a strong base with a weak acid. It's the same net ionic equation. It's just different things are in the beaker, different in the Erlenmeyer, different things are in the burette. Net ionic is the same though. Okay, what's next? A very important question to ask yourself at the beginning of every titration problem you start to work is, what's in my Erlenmeyer? So if you have only a weak component, I do know how to spell, but it really does not look like it when you watch me write. Only a weak component, you'll do an equilibrium thing, a rice table kind of thing, to find the concentration of the species in there. If you have only a strong component, you will do a limiting reactant thing, is sort of how we've said it, but you will find the concentration of the strong thing, and you can find pH from there, because usually that's the target of a titration problem, find the pH at various points. If you have a mixture of strong and weak, you will do a limiting reactant and then reassess. You do a limiting reactant table, and at the end of the limiting reactant table, you ask yourself, what's in my Erlenmeyer now? And if you have only a weak component, you do a rice table. If you have only a strong component, you do a limiting reactant, find the concentration of the strong component, and convert to pH. If you have a mixture of weak things, that means weak acid and weak base as conjugate pairs. That's a buffer solution. And a buffer solution can be solved with a Rice table, standard old protocol stuff, or it can be solved with a Henderson-Hasselbalch equation. It's up to you where you go from there. So once you realize you have a buffer, you can do either. So if you have a strong and a weak, you do a limiting reactant table and ask the question again. If you have only a weak, you do a Rice. If you have only a strong, you do a limiting reactant. If you have a mixture of weaks, you can do the buffer equation or a Rice thing. So titrations can be tough, and coming up with the equation or for how the titration starts can be tough, but I really have faith in you that you can do this. I hope that what I'm giving you is not so much a recipe, but more guidance on helping you get started on these types of problems. All right, goodbye.